Hello everyone, welcome. Today I will try to discuss about a very important topic for linear regression, and I also try to show you that how you can easily make the linear regression between NDVI, means that normalized difference vegetation index, and land surface temperature, and also predict the land surface temperature based on NDVI. So I hope in this class you are able to learn all of the basic things of linear regression, and also learn how to use this for predict LST based on NDVI. So mainly here I use the machine learning with Python, and also use here the linear regression with Python, and finally predict the LST. So I hope from this knowledge you can do any types of linear regression, and also predict any types of feature. So here I use the Google Earth Engine and also use the Python. So let's go. So first of all, I will try to discuss about the some basic things of regression. So first of all, what is regression? So mainly regression it used for find out the relationship among variables. It can be NDVI, LST, or any other types of variables. So mainly it find out the relationship. And then regression is used when you try to find out the relationship between variables, two variables, three variables. Okay, it depends on your work. And in machine learning and in statistical modeling, that relationship is used to predict the outcome of future event. So mainly when you want to identify any types of future what happened, then mainly we are using here the regression. And there are a lot of types of regression: linear regression, multi-layer regression. So in this time today's class I'll talk about the only for the linear regression, and also try to show you that how you can easily predict the LST based on NDVI. And then mainly there's a lot of work when you want to need the regression. So it need when you want to how some phenomena influence the other, or how several variables are related. So in this time I try to show you that what is the relation between NDVI and LST. Okay, and then it mainly useful when you want to forecast or need the future outcome or response using a new set of the predictors. We can also use the regression used to many different fields such as economics, computer science, and social science, as well as also GIS and remote sensing. Lot of uses in a regression. So mainly today I will discuss about the linear regression, and also show you that how we can easily use the linear regression using Python, and also predict the land surface temperature based on normalized difference vegetation index. So you can see this is a chart. In the chart it represented the x axis represented the NDVI value, and y-axis represented the land surface temperature in degree Celsius. So here I can get the two types of data, and in this data, when I create the base fit line, you can see it's called the base fit line. In this base fit line, we can create using the linear regression, and then we can easily use this base fit line and predict the future or other. Suppose in this time here I can get the data for 0.1. I can get this value. This is the data set for this 0.1 NDVI. So I can get this value almost 30 degrees Celsius. Okay, So in this time, when I want to predict, suppose 0 1 0 1 0 4 or 3 or other types of data which are not available in this NDVI, then from this base fit line it automatically predict what is the value for LST. So in this time, this task I also try to show you that using the Python linear regression, and also try to show you that how it will be work. And so mainly linear regression uses the relationship between the data points to draw a straight line through all of them. And this line can be used to predict future values. And this line called the base fit line. We predict the other values using this base fit line. Okay. And it's also important for the relationship. Mainly we can correlation for the R, and correlation mainly it identify the values of the x-axis, the values of the y-axis. What is the relation between the two variable? If there are no relationship, the linear regression cannot be used to predict anything. Okay, so suppose you want to get the relation, you can get the relation R value is that equal to 0. It means that there is the no relation. Suppose I can get the linear correlation R is equal to 0. It means that there is the no relationship. And when I did not find any types of relationship, it means that it there is the nothing for the predict. Okay, suppose I can get this R is equal to positive plus 1. So it identifies the highly positive relation between these two variables. And when I can get this value positive, we can easily predict anything. Same case, when I can get the value negative, it also means that the highly negative relation between the two variables, and I can easily predict. Okay, but when I can get the relation R is equal to 0, it means that there is the no relation, and when there is the no relation, we did not find any types of predict value. And the R value range from this range -1 to +1, and 0 means that no relation. And when I did not get any types of relation, it means that there is the no predict. We did not predict anything when I can get the R is equal to 0. Okay, so this is the basic things of that linear regression. So in this time, I just show you practical example and try to show you that how we can easily create this type of baseline, and using this baseline you can easily predict. Okay, so in this time I can simply go to my browser. So here I already open some data set of this NDVI and LST, you can see. And from this data set, I can simply open. Okay, so I already created an Excel file, you can see. So in this Excel file, I have stored my data. So here I can see the month. So this is the monthly data for NDVI and LST. Okay, so now I want to predict the LST based on NDVI. So NDVI is the feature and LST is the leveled. Okay, so I predict the LST using the NDVI. Okay, so here I can get the data set. This is my data set. So in this time, here I already installed the Anaconda distribution. If you don't know how to install the Anaconda distribution, you can also try to show my previous video class that I hope you can easily understand about that. So just I simply open the Anaconda distribution. So you can see. So first of all, you have to install some Python package. So basically in this time, I use here the Python package. So that's why you have to install some Python package, and then you can easily work with that. So first of all, I need the Python package for NumPy. So you can simply use here the pip install NumPy. So I simply write the pip install and NumPy. So now you can see it's showing the requirement already satisfied because I already installed it, the NumPy. Also need to pip install pandas library. So it already satisfied, you can see the requirement already satisfied. I also need to the install for pip install matplot library. Okay, so I already installed also these things. Okay, so you must be installed all of the things in here, and also need to install it the another things. It is the sklearn. We also need to install it the sklearn. So just simply write the pip install sklearn. So I simply fine. You can see already satisfied because I already complete all of the packages. So mainly this all of the package we need when you want to learn the linear regression. You must be install it all of the package in your system. Okay, so now I want to work. So first of all, I can simply open my Jupyter notebook. So I want to open the Jupyter notebook in my desktop. So I can simply change the directory and go to the desktop folder, and from this desktop folder I can simply open the folder for machine learning folder. I can simply open, and from the machine learning I open the linear regression folder. Okay, so now in this linear regression I just simply open the Jupyter notebook. Okay, so I simply write the Jupyter then notebook. So now we can see it opening the Jupyter notebook. So here I can write my code and also identify, make the future predict of LST, and also make the linear regression between the NDVI and LST. Okay, so now it opening. Okay. Okay, so here you can see it opened. So in this time, okay, so I simply create a new uh, file in here. So simply create the new Python file. Okay, so now I can simply import all of my library. So I simply use the import, such as import numpy as np. I also need import pandas as pd. Also import matplot library dot pyplot as plt. I simply run. You can see. Okay, so I think something wrong in here. Okay, so it will be matplotlib. Okay, so now click to the run. Okay, so now it can done. In this time you can see I import numpy package and give a new name np. I import pandas and give a new name pd. I import matplotlib.pyplot and give a new name plt. So when I want to call the numpy, I can simply use here the np. When I call the pandas, I can simply use here the pd. When I call the matplotlib.pyplot, I simply use here the plt. So I simply put all of the packages short name. Okay. So I put the short name np, pd, and plt. So future when I want to need this package, I simply call the np, pd, and plt. Okay. So now I can simply create a new cell, and now I need to import this CSV file. You can see this file I already created in here. So this is a CSV file. This file I need to import in my code editor. So mainly when you want to import, mainly we need to use here the pandas package. So just I simply take a variable. Suppose I can simply put the variable, suppose df, and call the pandas. So you can see I give the pandas name as a pd. So just I simply call the pd and use here the read CSV. Okay, so then I simply call this. You can see this is my file name NDVI LST.csv. I can simply click to the run. Okay, so now I want to show my CSV file in here. Simply click to the run. You can see I can get my data set. So in this time I can get the total monthly NDVI and LST data. You can see I use this data and make the linear regression and also predict the LST based on NDVI. Okay, so I create a new cell again. Okay, so now I want to check. Suppose you can simply use at the depth and use at the head. You can get only for the default value. Now it's showing the 5. Okay, you can see default value for the 5. When I want to combine, suppose I want to show only for the 2 value, click to the run, you can see I can get only for the 2. Okay, so there are the lot of new functions, such as if you want to check the data set shape, all of the things we can easily do in here. So in this time, first of all, I just create a chart. Suppose using this data set, I want to create the chart and then try to show the what will the chart look like. So simply click on here, and then I simply call the matplot library and I put this name PLT. Okay, and I want to create the chart scatter. Okay, after that I simply call my data set df. It will be stored my data set CSV data, and put here I put the NDVI, and also call the df and put here LST. Okay, now click to the run. Okay, so now you can see it's showing the scatter chart look like this. Okay, so this is the X level and Y level. I also put this X level Y level name. So I simply call this PLT. It is the matplotlib library, and set here at the X level. I put this X level such as it's the NDVI, and also put the PLT and put this Y level such as LST. Okay, and it is a string. You must be used at the single quotation start and end part, and also put here. Now click to the run. You can see I can get the result look like this. You can see it now showing that X level as the NDVI and Y level as the LST. So if you want, you can also put this chart title. So PLT dot title, and put the title. Suppose I put this title monthly NDVI and LST. Okay, now click to the run. You can see it also generating the chart look like this, monthly NDVI versus LST. So if you want, you can also you can see now it will be doing this is a circle. So if you want, you can also customize design in here. Okay, so for that you can simply write the sum function. You can simply use at the marker and put the marker. Suppose in this time I simply use this symbol instead of the circle, and also need to use at the quotation sign, and also put this. Suppose I want to see the color as a red color. Now click to the run. So now I can say I can get the result look like this. Okay, I can get this multiplication sign in here, also get this red color in here. So this is the scatter. I can create the chart look like this. Okay, in this time I want to predict the LST based on NDVI. So in this time you can see if I want to put this equation like this. Suppose I simply put this equation. You can see y equal to mx plus c. So here x is independent variable and y is dependent variable. So in this time x, so in this time I want to predict LST based on NDVI. So NDVI in this time, it is that independent and y is the dependent. Okay, so which variable is independent, it also called the feature, and feature always will be two-dimensional, and this labeled or dependent variable is one-dimensional. Okay, so in this time I want to create this data set. From this data set I can simply separate. You can say I create this my data set. In this data set I separate NDVI and LST. Here NDVI is the x mainly it is that independent, and LST is the dependent, because I want to predict LST based on NDVI. In this time I need to separate NDVI and LST. I need to separate. So for that I simply take a variable. So I simply take a new cell and put a variable, suppose x, and I simply call this dataset df, and it is a feature. X is the NDVI or independent. Okay, so it's a feature. You must be used at the two square bracket and define this NDVI. Okay, so I simply click the run, it will be run, and also take the another cell and take the another variable such as y, and I put here the dependent, so df, and call this LST. Okay, click to the run. So if you want to see the results separately, so just simply take a new cell and call the x. Now you can get, I check it again. Okay, I think something wrong in here. Okay, just I simply check my previous code. Okay. Okay, just I simply type. Okay, so you can see this is a chart we can create it. After that, we need to separate this data set. So just I simply use the xdf and xdil. So I want to show the x value in here. You can say I click to the run again. So here I can get all of the x value. You can see here I can get all of the x. So it's different the NDVI. You can see this is all of the NDVI, and also click to the y. So here I can get all of this y value in here. So I can simply run again. After this, I can get this x and y value from here, and from that, okay, check the again data set. Okay, so I can get this y data. You can see I separate the data set. This is the x, so x is that feature data. So that's why I can simply use it the square bracket, and this is my another data set. This is the level data set. Okay, so I simply use the square bracket. So this is the NDVI. All of the data is separate, and also separate. You can see all of the data for LST. Okay, so now I want to from this data set NDVI and LST, I want to use some data for train my model and also use for some data for test my model. Okay, so for this I can simply use a function. So I can simply take a new cell. Suppose I simply take a new cell in here. Okay, so in this time from this data set I use some data for train my model and also use some data for test my model. So for that I need to call a Python library. Okay, so for this I simply call the sklearn. So simply use the from sklearn dot model, use the selection and import train test split. Okay, so I simply import this. Okay, so imported. So now I can simply from x from the NDVI I take train dataset as well as also test dataset, and from y or LST I take the train dataset also test the test dataset. Okay, so for that I can simply take a new cell in here, new cell, and put this. I can simply use the x train, also put here this x test, also put here this y train, and also put here the y test. Okay, and after that I can simply call this train test split this, and also in this time I can simply call my x and y, which I separate. You can see x is the NDVI, y is the LST, and also need to mention here the test size. Test size. So here I simply use here the for the testing. I use here the 30% data. So I simply put here this 30% data for test, and rest of 70% data I use for train my model. Okay. So now I can simply click to the run. Okay. I take the new cell again, and now to check the X train. X train all of the data I want to check. You can see. So here I can get the X train, all of the data you can see for the X train. Okay, this is data I can get as X train data set. And in this time, if you want, you can use here the random state function. So then this data set will be taken randomly. Suppose I can simply use here the random state, random method, put the integer value such as 1, then run again, and also run again. In this time you can see this data set, it will be not select from the first and also not from the select from the last. This data set is taking randomly. Okay, you can see 1607. Okay, so this is the January, then it is the June. Okay, so it will be take this randomly. Sorry, this is January, then one is the February. Okay, so this randomly take. Okay, then you can see November. Okay, it randomly take in here. So in this time I also check the data, such as I take the new cell and also check the data for y train. You can see here I can get the y train data is this in this time for the LST same. Suppose you can see 1, also I can get the 1. So this data set is the February, this is the February. You can 6, I can also get 6. It means that June, also it's June. So 0, you can see it's also 0. So this is January and also January. Also you can see 7, July, I also get the July. So I can get the same. Okay, so the X train and Y train, again the same data set in also in here. The same also X test and Y test in here. Okay. So now I can get this data set look like this. So in this time, I use this X train and Y train for train my model. So I use the regression model, linear regression model. So in this time, I need to call the linear regression model. So I simply take a new cell in here and simply put here such as call the from sklearn and use here the linear model, and from import the linear regression, because I use here the linear regression. Okay, so I simply import this linear regression and click the run. Okay, check again what is the problem. Okay, so I spelled the wrong linear. Okay, now it okay, you can see. And then I take a new cell again. After this, I can simply create an object. Suppose I put this object is that model. Okay, and then I call this linear regression. Okay, and click to the run. So now my it is the stored linear regression model is stored in this variable. Okay, so now I use this variable and predict or calculate all of the things step by step. So take a new cell again, and now you can see model. So now I just use this model and train my data. Okay, so first I simply call the model, and then I can simply use a function fit. So mainly we are using the fit function. It mainly train our model. So in this time I use the X train and also call the train dataset for Y train. Click to the run. Okay, it's done. So now I want to predict. I want to predict the dataset. Okay, what I can get, you can see. I can simply use here this another cell. Such as I simply put this. I call the model and use here the predict function and predict the X test. So X test. Click to the run. In this time, you can say I can get the look like this for LST 12.56 degrees Celsius, 32.01 degrees Celsius, 32.01 degrees Celsius. Okay, so I can get this data set look like this. So if I want to check the value, suppose you want to check the X train, you can see for the X train, you can see I can get the value for when I can get the NDVI 0.105, I can get the value such as 12.5. Okay, so if I want to print this X train again and try to show that, so I simply create the new, yes, I simply create a new cell in here and simply call the X train. So here I can get all of the value new, you can see. So in this time, here I can get, you can see for that 0.1 for the NDVI, I can get the value 12.56. 0.100, I can get the value look like this. 0.104, I can get the value look like this. 0.101, I can get the value look like this. Okay, so it predicts some value from the NDVI. Not only for that, if you want to show that how it will be work, so mainly this work will be done from the base fit line. So if you want to show the base fit line, you can easily try show the base fit line in here. So for that, I can simply take a new cell in here. So I simply take a new cell and create a base fit line. So I simply call this PLT plot and also use at the plot function. Plot function. In this plot function, I can simply create the base fit line. So call the my data set. From this data set, I call the NDVI. Okay, and then call the model. From this model, I just use the predict function and predict the DF and use that the this is the feature. For that, I simply use the double quotation and put here the NDVI. Okay, I need to use that the quotation. Okay, so now you can see it create the base fit line in here. So I can get the base fit line look like this. So from this base fit line, we can easily identify for the LST and NDVI, this correlation is a negative correlation. So here you can see when I can get the low NDVI value, it's showing the high temperature. When I can get the high NDVI value, it's showing the low temperature. Okay, so from the chart, we can say that the NDVI and LST, this correlation is that negative. So here I can get this value look like this. So in this time, it also better understand. You can see, just I simply copy from here. Suppose my previous, so just I simply copy this chart from here and paste. And click to the run again. So in this time, you can see it create the base fit line. And from this base fit line, we can easily identify or anything predict. So in this time, you can see I can get this data for this point. For the 1.08, I can get the LST for the 15 degrees Celsius. Okay. So when I can get the high NDVI, I can get this low temperature. When I can get this high temperature, it means that there is the low NDVI value. Okay, and from this base fit line, we can easily predict any NDVI value I can put, and it's showing the result. Suppose in this time, I create a new cell again. So I simply call my model. I simply call this model, suppose model, and use here the predict, and you must be use here this double quotation. Suppose I want to predict for this 0.9. When the NDVI value is the 0.9, what is the temperature we can get? We can check it. So I can check the value. So you can see, according to this model, we can get the very, very low temperature. In this time, when I want to put the value 0.9, very high NDVI, it's showing that very low temperature. It, in fact, in this time, it's showing as a negative. Okay. Suppose I put this value look like this. Suppose 0.109. So in this time, you can see when I can get this ND value 109, suppose 0108, and after that 109, it's showing also low temperature, 7 degrees Celsius. So when I want to put this value, suppose 100, then I can get the value. You can see I cannot. So this is time it's like 51 degrees Celsius. You can say I can get for the 101. So I can get the value 51 degrees Celsius in here. For the low NDVI, I can get the high temperature, and the high NDVI, I can get the low temperature. Okay. So then in this time, if you want to show, you can say I can get the any predict. So in the base fit line, from the base fit line, we can easily predict any types of NDVI value we can put, and it will be showing this result look like this. So in this time, if you want to show how it will be work, so mainly it will be work using this equation. So this equation is that y equal mx plus c. So here m is that we can say that this is that coefficient. So we can use that the solve, and this is the c is the intercept. So if you want, you can also calculate it from this chart. What is the coefficient and what is the intercept? We can easily calculate it. So for that, I simply create a new and also call the model, suppose model, and then use at the coefficient. I print. So I can get the value. This is the coefficient value. So I take a new cell and also try to find out the c value. C mainly this is the intercept. So I simply call this model and use here the intercept. Sorry. Okay, I can get the intercept value. So now you can say I can get this m value. This is the coefficient I can get. Also intercept value, I can get the c value. And when I put the x value, suppose in this time I can x value, suppose 0.10, it automatically show the result. So if you want to check the value, so I simply try to show you that how to work. So suppose I simply put here the y is equal. So I simply put here the m value. So m is that I can simply, this is the coefficient. So I simply copy this value from here, simply copy and paste, and then I simply multiply with my x value. So in this time I simply predict this value. So simply copy this NDVI value and paste in here, and then plus c, this is the c value, intercept value. I simply copy and paste. Okay, so now I try to find out the y value. What the value I can get, you can say simply print this. So here I can get the value for 51. You can see I can get the 51 degrees Celsius. So I can get the value 51 degrees Celsius in here, and I also predict the value according to this base fit line 51 degrees Celsius. So basically this we can easily predict any types of prediction using the y equal to mx plus c. Here this is the m, and this is the solve or coefficient, and c is the intercept. These two value m and c, this two value is the constant for this base fit line. Okay, just in this time we can simply put here the x value. So x is the NDVI. We can simply put here the NDVI value, and we can easily predict the LST. So in this time, this x is the independent and y is the dependent. So x is that independent, so that's why it will be feature, and feature will always be two-dimensional. And when you want to print any two-dimensional, we must be using the two square bracket. Okay, so I hope you can easily understand about that linear regression and also predict the LST and NDVI. So using this model, you can easily predict anything from any data set. So in this time, I take the data set randomly. So I take the use this data set randomly. So you can use any types of data set, any types of data set you can use, and then easily find out the prediction for the other values, and also make the correlation. So if you want to check the correlation about the data set, so just you can simply print this model score. So I simply try to show that I can easily get this correlation values. So for that I simply take a new cell in here. Suppose I take a new cell and then simply call my model. From this model, I just simply call the score, and a score between X train and Y train. So I can get this to 0.5. Okay. So in this time, this 0.5 is it's not the high positive value. So it is the middle. So there's some correlation between LST and NDVI. We can say that from this data set. Okay. So using this data set, using this process, you can easily find out the any types of prediction value. So if you have any question, you can also ask in our comment section. And if you want to join my online training program, I will give you all of the information in the video description, and I also give you this all of the practice code in my WhatsApp group and Telegram group. So if you want to not join, so as soon as possible you can join, then you can easily get the all of the practice code and also practice for your own system. Okay. And if you want to join my online training program, you can just contact with me. I will give you the all of the information in my video description, so that you can easily contact with me and join. Okay. So thank you for watching.